Today we're going to continue our discussion of correlation, and you can see that we've got some graphs right here that have a positive correlation, but clearly they're not all equal to each other. This one is spread out quite a bit, and yes, it's going up and to the right with its positive correlation, but it's not lined up very nicely. Whereas this one on the other side goes up and to the right, and the points line up perfectly in a straight line. So our line the best fit would fit this one very nicely, perfectly. It would fit this one really well, but not perfectly. But if we get over here, our line of best fit wouldn't fit this one particularly well. We can see the same thing for our negative correlations, where we line up nicely right here, and we're starting to get more spread out as we go along. And then this one is going down and to the right. It's got a negative correlation, but it's scattered quite far. And so our next task on this is to explore an idea called correlation coefficient. Correlation coefficient gives us a way to tell how nicely things line up and how accurate our line of best fit will be. So correlation, meaning a connection between two things, and coefficient is a name for a number, in this case a number that measures that connection. Now I want to hit briefly this graph right here. This one does not have a correlation. It doesn't go up, it doesn't go down. Things are just scattered and we can't really tell which direction, or there is no direction that it heads. Okay, now correlation coefficients are always going to end up being between -1 and +1. And you can see that I've broken it down into some different numbers right here that are the exact same thing on the right-hand side, on the positive as well as the negative side. And so once you've memorized one of these sides, you'll be able to understand the opposite one as well. Okay, so if the correlation is 1, that means it is perfect. That means that the points line up in exactly a straight line and the line of best fit fits those points perfectly. If your correlation is 0, there is no correlation at all. So you shouldn't draw a line of best fit because there is no correlation. It doesn't go up, it doesn't go down. That line of best fit wouldn't show us anything. Now, from our previous graphs, it's clear that it's not just no correlation and perfect. There are things in between those two where it lines up very close or it gets scattered farther apart, and that's what these numbers break down. And so this following scale won't be agreed upon with everybody. If you go and look on the internet, you'll see a bunch of different breakdowns of this, but the purpose of this is as you get closer to 1, your correlation gets stronger. If you get farther away from 1, closer to 0, your correlation gets weaker. So you can always compare scatter plots and see if it's stronger or weaker, but I also like to have these vocabulary words to describe our relationships. So this area from 0.7 to 1, we are going to categorize it as strong. If your correlation coefficient is in this area, then it is a strong relationship. That line of best fit will fit nicely. The points will line up very well. It's not perfect. Perfect is 1, but it does line up very nicely. Between 0.5 and 0.7, we are going to call moderate. That means that the correlation is there, it's medium in its strength, and so our line of best fit will be a medium level of accuracy. Between 0.3 and 0.5, that is going to be titled weak. That means that there is a correlation, it's going up and to the right, but it's spread out. And our line of best fit won't be very accurate at all. And if it's between 0 and 0.3, there is no correlation. So we're going to kind of lump this together all in that category right there. Now, on the negative side, we have the exact same categories. So we're going to add those to this. From -1 to -0.7 is again strong. From -0.5 to 0.7 here is going to be moderate. From -0.3 to -0.5 is again going to be weak. And from 0 to -0.3 is again going to be no correlation. All right, the difference between the positive and negative is that if it has a positive correlation, there's a positive slope to the line of best fit. And if it has a negative correlation, there is a negative slope to our scatter plot or our lines of best fit. So let's go back to our graphs over here and let's give them a title. So we have first this graph that lines up perfectly. That means its correlation coefficient is going to be 1 because it's exactly along that line of best fit. Every single point right here fits that line of best fit exactly. This one is going to be a strong. So this is perfect. Forgot to write that down. This is strong. They don't line up perfectly along the line of best fit, we can see, but they are very close to it. So this is a strong. This is our example of moderate. And this is our example of weak. And you can see as we get weaker, they get more spread out, and our line of best fit becomes less and less accurate. So this is a nice way to support your line of best fit, or to say that the line of best fit doesn't fit it particularly well. Now on the negative side, we also have perfect. So these line up perfectly. That means our correlation coefficient again is 1. This is strong, which means our correlation coefficient is somewhere between negative 0.7 and negative 1. Here is moderate. And here is weak. It's again spread out. And you can tell it's going down, but it's not very accurate at all. Now, we're going to use the computer to do the correlation coefficients. It's really a lengthy calculation to do by hand. The computers can do it fairly quickly, so I'll show you how to do that in just a second. But our job is to be able to interpret the correlation coefficient when it's there so we can support, yes, our line of best fit is very, very accurate, or no, our line of best fit is not very accurate. All right, let's take a look at this question right here that shows the number of people who volunteer at an animal shelter on a given day. So we are tasked with finding an equation for the line of best fit, which we will use GeoGebra to do again, like we did in our last section. We are to identify and interpret the correlation coefficient and interpret the slope and the y-intercept of the line of best fit. I have taken those points and I've put them on GeoGebra here as a scatter plot, and you can see that they are going up and to the right. So we should expect that our line of best fit will have a positive slope, or there is a positive correlation. So let's go ahead and do that line of best fit first. We have the command fit line, so in my inbox down here to the left, we'll type in fit line again. And inside the parentheses, I'm going to put my points A, B, C, D, E, F, G, H, and we're finished with all of our points. So again, our positive correlation showed up in that as we expected. We have our slope right here is 1. There is y equals 1x, and our y-intercept is 6.75. So let's go ahead and interpret that slope. That means that our rise is 1 and our run is 1. Now, as we go to the right, 1, that means that we increase, or one day has passed. So after 1 day has passed, we've also gone up by 1, and that means that there is 1 extra person that volunteers. So that's the meaning of our slope. Every time 1 day passes, we get 1 extra person for our volunteers. And our y-intercept of 6.75 shows us that on the original day, the day 0, which would be when we started, we had 6.75 people. Now, that's not accurate, of course, because we can't have exactly 6.75 people, so we'd probably round that up to 7. Okay, let's do our correlation coefficient. And we'll get a strength level because clearly this doesn't fit exactly our points. They're scattered along the above and below our line of best fit. So the command for correlation coefficient is cleverly titled correlation coefficient. So we'll type that in. And you can see that it pops up and tries to help us with spelling and things. So we're going to put our points in there again in the parentheses: A, B, C, D, E, F, G, and H. And when I hit enter, it will give me a value for our correlation coefficient. Now, this number is usually not going to end up being a nice number unless it's 1. So I round it to 2 decimal places typically. That would be 0.62. If we go back to our scale that we showed for correlation coefficient, we can see that that fits in the moderate category, which means our line of best fit fits moderately. So it won't be particularly accurate, but it's not weak. It does have a medium correlation. So we can see that these points are not right along there. They're spread out above and below, but they still have a medium relationship. So that is the end of our question, and that correlation coefficient will tell us exactly how accurate we expect the line of best fit to be, and the line of best fit will help us to make predictions for future days. Thank you.